The first question is just simply a fact we are to know. This is something you looked up when you were doing your length measurement lab, and that conversion is 1 inch equals 2.54 centimeters. We could also write it like this, 1 inch for 2.54 centimeters, or we could write it as 2.54 centimeters per 1 inch, like so. 3 different ways we could write it. Similarly, in the mass measurement lab, you were asked to look up the conversion for mass, English to metric, at standard temperature and pressure, sea level. We have a conversion wherein 1 kilogram equals 2.2 pounds. So we could write that as 1 kilogram per 2.2 pounds, or also 2.2 pounds per 1 kilogram. The next question is more involved, using dimensional analysis to show how many meters per second and 10 miles per hour. So the thing we're given is 10 miles per hour. So we'll start out with 10 miles per hour. And so there's 2 things we need to do. We need to convert hours to seconds. We need to convert miles to meters. We can start with either one. I'll just suggest we start with the miles to meters. And that conversion we have in the English system is at the centimeters level to inches. So I've got to get miles to inches. So I'm going to multiply this by a fraction. And I want miles to go away. So miles will be on the bottom. And I know that 1 mile is 5,280 feet. And now I need to get rid of feet. And so feet will be on the bottom here. And we can convert feet to inches. 1 foot is 12 inches. So now we have inches per hour. The miles cancel, feet cancel, and we're left with inches per hour. So to get to meters, we now are going to convert to the metric system, and we want to get rid of inches. So we have inches on the bottom, and our conversion is 1 inch is 2.54 centimeters. And now to get to meters, we want to get rid of centimeters, and so the centimeters and meters. When I'm doing conversions like this, I always ask myself which one is the larger unit. In this case, the meter is larger. So if I have 1 meter, I have 100 centimeters. So now inches are gone, centimeters are gone. And when I multiply all of this out, I end up with meters per hour. But I need meters per second. So I've got a few more conversions here to get from hours to seconds. So hours was on the bottom, so I need hours on top to get rid of it. So hours will go to minutes. 1 hour is 60 minutes. And then from minutes to seconds. To get rid of the minutes will need to be on top, seconds on the bottom. 1 minute is 60 seconds. So now, when I look at all of my units, hours have canceled, minutes have canceled, and on the top, what I'm left with is meters, and on the bottom, I'm left with seconds. So mathematically then, I just have my numbers to multiply out. And that's going to be 10 times 5,280 times 12 times 2.54. And that's going to be all over 10 to the second times 60 times 60. And that'll be meters per second. The mathematics is easy at that point. Now for the light year. Now what we know is we're starting out with the speed of light, which is 3 times 10 to the 8th meters per second. So we're looking for how many meters in 1 year. So we've got to go from seconds to years. So to get rid of seconds, seconds will be on top, and we will go to minutes. 1 minute is 60 seconds. That gets us meters per minute. And now we'll go to hours. Minutes must be on top. And 1 hour is 60 minutes. And then we can go to a day. To get rid of hours, hours will be on top. Hours per day. 1 day is 24 hours. And now to go from hours to years, hour would need to be on the bottom and year would be on top. And so 1 year would be 300, oops. I'm going to get days here, excuse me. Days per year. And 1 year is 365.24 days. So going back here, we have meters, seconds cancel, minutes cancel, hours cancel, days cancel, and we're left with meters per year. So mathematically then, we have 3 times 10 to the 8th times 60 times 60 times 24 times 365.2422, and that would give us meters per year, which is 1 light year. Of course, we multiply all those numbers, we get 9.46 times 10 to the 15th meters per year. This next one asks us to use dimensional analysis to analyze a formula for the area of a trapezoid. So first of all, we need to know the area of a trapezoid formula. So the area of a trapezoid is 1/2 base 1 plus base 2 times the height. So if I now put in units, 1/2 is a constant, it doesn't have any units. So when I look at the units, I now have meters plus meters. And height is also measured in meters. The base lengths are measured in meters and the height's measured in meters. Well, when I'm adding meters, say 3 meters and 4 meters, I end up with 7 meters. So the units of this is meters. And that's going to be multiplied by meters, which would be meters squared. Now we would expect that all area formulas would yield an answer of meters squared for the units of area. All right, so use dimensional analysis in our final question to calculate the weight in newtons of a 5-pound bag of sugar. So we're starting out with a 5-pound bag. 5 pounds. We want to go from pounds to kilograms. We're cross systems here. So 5 pounds, I need pounds on the bottom and kilograms on top. Well, we know 1 kilogram is 2.2 pounds. So that gets us to kilograms. And how do we get to newtons? Well, we might remember that we multiply the number of kilograms times 9.81 meters per second squared. And that then would give us 5 times 9.81 kilogram meters per second squared, which happens to be 1 newton, which happens to be newtons. So 5 times 9.81 newtons.